Hi, so I'm Tristan Hume. I'm a UWaterloo student, and I work on Rust in my spare time and one co-op job that's only somewhat related to this. So the project I'm going to talk about is Syntect. It's a syntax highlighting library for Rust, and it's used mostly, it was mostly intended when I built it for, there were various text editor projects cropping up written in Rust, and none of them had gotten around to syntax highlighting yet. So I was thinking like, instead of contributing to one of those, then I can just write a syntax highlighting library that all of them can use. Yes?
Can you do Control Plus?
Okay, more? So nowadays it's used by Xi and some of the other text editor projects, and also it's used by two commercial products, one of which I can't tell you about, or they don't want me to tell you about, and one of them is SourceGraph, if you've ever heard of it. It's like a code search tool online, and they do all their highlighting with Syntect. And it's also used by some other like small projects, some static site engines, and some web or like little command line tools for printing out markdown files with highlighted code blocks, or printing out code files highlighted for you. Yeah, so what it does is it's a replica of Sublime Text syntax highlighting engine. And Sublime Text open sourced all their grammars, and a lot of these kind of style files are also available open source. So Sublime has this very powerful syntax highlighting engine that gives very rich information. So it can give lots of nice colors, and also, let's see if I can do this keyboard shortcut. Oops, that's the wrong one. Nope, also the wrong one. I always forget the shortcut. Okay, never mind. Shortcut's not going to happen. But basically, it has these, all parts of the document have these very rich kind of layered representation embedded in it. So this will say like, it's a keyword that's a module-related keyword in JavaScript. And then it'll also have a stack saying, and this is inside of an if expression, inside of a function, inside of a JavaScript file. So this was a good starting point, and one of the reasons I wanted to reuse Sublime's grammars is that the Sublime grammar files are these JSON files that are fairly easy to, or I thought at the time, fairly easy to interpret. And they can get pretty large. So this JavaScript grammar is 1,500 lines, because it includes all sorts of fancy ECMAScript 6 features and things. And this is in a fairly compact representation compared to some other ways of writing grammars. And it uses regular expressions. And Sublime's packages has 30,000 lines of these, and that's just the ones that are included with Sublime Text. Third parties have written all sorts of other grammars, so they're probably like, if you want to cover all the languages that people reasonably use, you probably need like 50 to 80,000 lines of grammar. And it just seemed unreasonable to start those from scratch in a new format, even if the new format would have been faster or better in some other way. And also there's these nice highlighting files that give nice themes. These are just XML files that come from TextMate, and they use selectors on these nice expressions. So you can say like, I want to highlight strings and symbols, which are a Ruby thing, and maybe inherited classes. So that's nice. Anyway, it can also be used, this rich representation can also be used for cool things like reading kind of semantic information. So I have this program here. I'm going to need to do Command+ in my terminal too. That uses Syntect to count lines of code. It's not the fastest tool, but it gives you a bunch of things that you couldn't get otherwise without this fancy representation, like the number of functions and the lines of documentation comment versus normal comment and things like that, which is cool. And it can also auto-detect all your file types. And I also have another example, which is, I'm going to need to make this terminal bigger. I have it using full RGB terminal escape code supported by some terminals to print files in the command line. So this is a file highlighted with Syntect. And one of the great features of Sublime's highlighting that a lot of highlighting engines don't support is nested languages. So here we have an ERB file, which is like a Ruby template HTML file. So it has a script tag that embeds JavaScript, that embeds a Ruby interpolation, which has these HereDoc strings, which a lot of parsers don't support. And one of these HereDoc strings is an SQL HereDoc string that has SQL in it. And all of this is highlighted correctly. And exactly the same as Sublime Text. And it's also, I took pains and did a lot of profiling and optimization to make it very fast. So it can highlight all, I think it's 10,000 lines of jQuery in half a second, and that's including starting up and loading the file and loading all the grammars. So Sublime also does this very fast, in fact, faster than us since they have a custom regex engine. But if we go into Visual Studio Code and select the jQuery file and then go to the bottom because they have lazy syntax highlighting, you'll see it takes substantially longer than half a second. And there. So we're one of the fastest syntax highlighting engines. And that's pretty cool. And then that's, I think, all I have to show. Yes. So that's Syntect. It's a syntax highlighting library. Oh, I also have, it can output HTML files for you. So this is jQuery as an HTML file. And it also has very good documentation. All the methods are documented. There's examples that show, like, there's also this easy module. I made it so that the API is very powerful for like text editors that want to go super fast. So here's the example of Xi. It's one of the text editors that uses Rust or syntax. It also uses Rust. But while Syntect supports these fancy caching workflows where you can like cache parsing states so that you don't have to reparse everything when the person in your editor makes small changes, those APIs are much more difficult to use than most people would want to use. So I have also this easy module that just gives you easy ability to highlight whole files at a time and auto-detect syntax and all that kind of thing. Yeah, so that's it. Any questions? Nope. Cool. Thanks.
I'm working in a library called McVean, which is the name of a famous photographer that basically does image processing on pictures of people. The main use case is this problem that I was trying to solve. So I wanted to build an app that once you send it the picture of a soccer player in the field, it's able to recognize which soccer player it is and hopefully send some statistics. All this in the context of the current World Cup. So I thought, well, why don't I do it in Rust? The problem is that there is currently no tooling to do this. In C++, for example, you have a wonderful library that is called DLIB to do image processing and, in general, machine learning stuff. And in Rust, there is only CVRC, which are bindings for the OpenCV library. It's a wonderful library. I highly recommend it. So I decided to create a new library that will have bindings to the DLIB library in C++ and a tool to do picture analysis from this DLIB library and OpenCV. The features that it's right now doing is basically face localization and cropping. It's using a couple algorithms that are implemented in OpenCV. I'm working in doing feature detection right now, which is basically recognizing where all the different parts of the faces are located in the picture. And after that, the next step will be face frontalization, which is basically if you have a picture of someone giving you the, I don't know how to say it in English, the profile. Yes, you will centralize it so you see it as if they were in front of you. And lately, face encoding, which is basically representing a face as an array of vectors, so you can identify it. So if you have two pictures of a face, you represent them as an array of vectors, and you are able to calculate the distance between those arrays of vectors and estimate if they are likely from the same person or not. And those are all the slides that I had. I don't have any code, sadly, but I will send some. I don't know. Is there any question I can? Yeah.
Why did you decide to do this in Rust? I mean, follow this as a language.
That's a good question. Because I like Rust. Yeah.
Was it simple to make binding to the C library?
No. It was actually kind of tricky, and I based most of these on what the previous project does. Yeah, so that project, CWRS, had similar problems than me. There are some tools to do automatic bindings from C and C++ libraries, but I found that most of them just failed with complex libraries like DLIB or OpenCV. This tool, what it does, it's... Oh, I can actually show you now here. That will be nice. Because I found that it's a very nice and smart way to do it, and it's fairly simple. CV, GitHub. Yes. So if you see, there is here a folder that is called native. Yes. And in here, it has some C files that act as bridges between Rust and the C library. And it uses it at build time. It compiles these files and it links them with your library. And that works very, very well. And it's easier than trying to use the automatic tools that just fail miserably.
What if a player hits the ball with the head?
That was actually a problem. If you have I had the same problem. My tool at the beginning would recognize the ball as a face. A good way to solve it is, so there are some parameters about the proportion of the faces that you want to identify, and adjusting that parameter, you can make sure that you don't get faces that more than one face in the picture that have hugely different proportions, which is what usually happens with the face. They have different proportions.
Where do you get your test data? You play soccer in front of the camera?
No, for the text data, I just scrapped the web. I use mostly Google Images. Yep.
So you said that there were two libraries, OpenCV and DLIB?
Yes.
And OpenCV already had a Rust implementation you liked, and you were writing one for the other one.
Yep, for DLIB.
What does that one do?
It's hard to say because it's a little bit like C++. It does everything. It has a lot of tools for image processing and a lot of tools for machine learning. I was interested mostly in the tools for image processing. It helps a lot with the part of feature recognition, for example. Any more questions? Hopefully in future meetups I will show code. Sorry for the technical problems.
So hi, I'm Michael. So the thing I'm going to demo is a thing in the Rust compiler I started working on a little while ago. So basically, well, let's just get started. So in Rust, you can have methods, right? And there's four kinds of methods you can have. There's ones that take self by value, or self by reference, by mute reference, or by box. You might not have seen this one before. And that's it. So I guess the easy question is why is box so special? And that's because it's special. Yeah, is everyone following me? Okay, sweet. One sec. So the feature that I added was arbitrary self types, or custom method receivers. So basically, anything can be a method receiver. Anything can be the self in this in a method, as long as it implements deref, the deref trait, with self as the target. So here I have an example using RC, like reference counter pointer. So here's a method that takes RC. So it takes like the self argument, the first, like the implicit first argument is an RC, and here's an example of it. I should probably run this so that you can see it. So there we go. It prints out by value, everything, see everything in these methods. Prints that out. It prints out by RC. And here's an example of something more custom. So if you want to make something that you can use as a self type, like as the receiver for a method call, it just has to implement deref. And so here's a struct. It's just a reference, but it's my ref instead. And here's a method for the foo type that takes my ref as the self argument. And it works. Yeah. So this also works for traits. Foo is a struct, but if you had a trait, you can have methods that take like RC or whatever custom method receiver type, except that it's not object safe yet. So like stuff like RC should be object safe. You should be able to have a trait object that with a method that takes an RC of the trait object, but it doesn't work yet. So that's the next thing I want to implement. And yeah, that's my demo. Oh, questions?
In which situations will you implement your own box-like structure?
I don't know, maybe you have like something in C++ and you need a special pointer type, like unique pointer or something. Might be an example. Tristan?
Wait, I basically forgot what my question is. I remember I had two questions. One of them was, is the main purpose of this for the new pin stuff, or? Yeah, pin is a custom method receiver, or whatever the name is for that, yeah.
Does this also work for deref mute?
Yeah, well, it's not, so basically you just have to implement deref for it to be usable as a method receiver. But if you implement deref mute, then it's, I guess, like, I don't know, it's sort of yes, no, kind of, yeah.
And is this in nightly yet?
Yeah, so there's a feature you have to use arbitrary self-types. Yeah. Anyone else? Mark?
Any idea when this will make it into stable?
Nope. Like, probably around the same time that pin and async await are stabilized, but who knows, maybe like a year or 2 years. It needs some work. I think there's some like edge cases that they're not like soundness holes, but just stuff that doesn't work that should work. That probably needs to be cleaned up. Yeah.
Mutable mutable reference is not dangerous?
What about mutable references?
Not dangerous programming practice?
Well, in Rust, mutable references are basically, you can, I mean, Rust like protects you from having shared mutable state that, you know, ends up causing undefined behavior. So it's not unsafe, if that was an answer to your question.
Just, I'm not very familiar. I'm just correlating with what was said in the previous talk about mutable and immutable references. Yeah? So I can extrapolate that by ref, it's immutable. Yeah?
By ref is immutable, yeah. By mute ref takes, apparently it doesn't go by mute ref. That's just a typo. Thanks. See if this actually works. Probably. Oh, it works. Okay. Why does it work? Oh, because like if I declared foo to be a local variable but didn't put mute, like let mute, and then here, one second. And then did this. Oh, whoops. Okay, so this won't work because foo's not mutable. Yeah. All right, that's it. Are there more demos or? No, that's it. That's it. All right, that's a wrap.